the purpose of this tutorial is to find the vertex from factored form. Now, the reason you would want the vertex from factored form is to help you when you're graphing. Right? Because if we're graphing a quadratic equation, you're going to get a parabola, and the most important point is that point in which it's changing from going up to going down, which would be your vertex. Or if it was facing up, when it's going from decreasing to increasing, which would still be your vertex. All right, so our goal is to find that point, and that way we can use symmetry to our advantage when we're graphing, and it'll also guarantee that we found the highest or lowest point. All right, to do that from factored form, well, if we know that there's symmetry about the graph, so again, if I have a parabola, and I can see my x-intercepts, the vertex is halfway between the x-intercepts. All right, that's important because when we're in factored form, we can actually find the x-intercepts rather quickly. All right, so x-intercepts are when your output is 0. So simply we just have to let f of x equal 0. So if I say x plus 5 times x minus 1 equals 0. All right, this is using the zero products property, meaning that we know something special about something that has a product of 0. Either x plus 5 is 0, or x minus 1 must equal 0. And the reason we know that is if you picked any two numbers in the world to make a product of 0, one of them has to be 0. So now I can say x plus 5 is equal to negative 5, right? And x minus 1 is equal to 1. And we know those are going to give us an output of 0. So if I go into my table, I have negative 5, 0. That's one of my x-intercepts. All right, and I would have positive 1, 0. The vertex is not going to have an output of 0, and its input is halfway between negative 5 and 1. So if you're finding the middle value or a midpoint, you're just finding the mean, right? So you would just add those two numbers together, so negative 5 plus 1, and you're dividing it by 2. So negative 5 plus 1 is negative 4. Negative 4 divided by 2 is equal to negative 2. So that just gives us our x-coordinate for the vertex. To get the y-coordinate, we would then plug that back into our original equation. So now I would be able to show, well, f of negative 2 is equal to negative 2 plus 5 times negative 2 minus 1. All right, negative 2 plus 5 is positive 3. So f of negative 2 is equal to positive 3 times negative 2 minus 1 is negative 3. And a lot of times you'll see that the vertex, the two numbers will repeat. Like we have 3 and negative 3, or you might have 3 and positive 3. Right, so f of negative 2 is negative 9, meaning the lowest point, or the vertex, is the point negative 2, negative 9. All right, and this is usually done in the context of graphing. But if it's not done, if we're just isolating the skill, we can kind of break down each of those parts. Right, so if we look at this new problem where we're finding, again, from factored form, and it's factored form because we have two pieces multiplying together, first thing we had to do is find the x-intercepts, which is when this is equal to 0. And so that means that either x minus 1 is 0, thus x is 1, or x plus 7 is 0, and so x is negative 6. Excuse me, negative 7. All right, so the x-intercepts are 1, 0, and negative 7, 0. All right, the midpoint, specifically the x-coordinates, to find that, we add those together, so 1 plus negative 7, and we divide them by 2. You're finding an average, or a mean, right, to find the number that's halfway in the middle. Right, so 1 plus negative 7 is negative 6, divided by 2 is negative 3. So the point negative 3 is halfway in between, because negative 3 is 4 spots away from 1. It's also 4 spots away from negative 7. All right, now to find, so that gives us the x coordinate. To get the y coordinate, we're just plugging that in. So we'll see -3 take away 1 times -3 plus 7. And just like before, you'll see the same number pop up. All right, I see -4. I'm also getting +4. And -4 times +4 is -16. And that's how you find the vertex from factor form.